Find the volume of the solid. Obtained by rotating, really abbreviate here, the region bounded by y equals 2x squared minus x cubed and y equals 0 about the y-axis. Okay, so that's the one we just talked about. It's this shape here. I'm going to rotate about the y-axis, this portion here. I want to integrate with respect to x, obviously. I don't want to integrate with respect to y, do I? Because another reason is try to solve that for x, right? If you integrate with respect to y here, I'd have to solve that for x. And that is not going to be easy to do. So I definitely want to integrate with respect to x. Well, if I want to do that, that's parallel to the y-axis, isn't it? That's shell method. And the shell method is the integral of 2 pi x f of x dx, a to b. Okay, so that would be, in this case, 2 pi x f of x, well, that's my f of x. It's 2x squared minus x cubed dx. What about my limits of integration? Well, it looks like it's 0 to whatever that point is. So I just set those two equal. Two x squared minus x cubed. Factor off an x squared. Thank you. So that would be 2 minus x. So that would be, yeah, x is 0 and x is 2, wouldn't it? So that is 2. 0 to 2. Is everybody with me on that? How do I integrate that? What would be my first step? Got to distribute the x. Yeah, most of these cases on the shell method, you are going to have to distribute the x. So that would be the volume 0 to 2 of 2 pi times 2x cubed minus x to the 4th dx. So now I can do the antiderivative. So that would be 2 pi times, add 1, that would be 4. It would be 2/4 x to the 4th minus 1/5 x to the 5th. Oh, already done dx, so it's 0 to 2. So I have 2 pi times, that would be 1/2 of 16 minus 1/5 of 32, wouldn't it? Minus 0. Basically 8 minus 32/5. Which gives me 8/5 times 2 pi, which is that right? 16/5 pi. That's what I get. Question? Okay. What about this one? Find the volume of the solid. Obtained by rotating the region bounded by y equals x squared minus 4x plus 3 and y equals x minus 1 about the y-axis. volume of the solid obtained by rotating the region bounded by y equals x squared minus 4x plus 3 and y equals x minus 1 about the y-axis. Excuse me. Okay, well, here's our picture. X squared minus 4x plus 3. Graph that in our old handy dandy calculator here. And x minus 1. So I'm looking like this. So I'm rotating that region bounded by those two about the y-axis. Which way do I want to integrate? Definitely want to integrate this way, don't I? Up and down, vertical. I don't want to go across there. For one thing, these are definitely good f of x's, but f of y's, I don't think they would be. That one would be. This wouldn't be that bad. But yeah, I definitely want to integrate this way, up and down vertical rectangles, which are parallel to the axis of rotation. That is which method? Shell method. Definitely want to use shell here. Now, the thing about it is, you know, your f of x, that's kind of your, it's 2 pi x f of x dx. The f of x is how high, the height of your thing that you're integrating. How am I going to get the height of that? Well, I've got to do a little subtraction, don't I? I have to subtract the top minus the bottom. So it's back to the subtraction, which is, you know, first thing we talked about in this. So it's 2 pi x, and to get that height, yeah, you've got to subtract the top one minus the bottom one. So it'd be the x minus 1 minus the x squared minus 4x plus 3. Because that would give me that height of that function. Now I want to go from, of course, the intersection points, set them equal, subtract the x and add the 1. So that would be x squared minus 5x plus 4. So yeah, that is going to work out nicely, isn't it? 4 and 1. Yeah, 4 and 1. So I want to go from 1 to 4. Okay, so integral 1 to 4, 2 pi x. There are some like terms here. Don't forget to change those signs. It would be minus x squared plus 5x minus 4. But then I have to distribute the x. So it would be minus x cubed plus 5x squared minus 4x is what I finally wind up doing the antiderivative of. Does that sound right? Minus x cubed plus 5x squared minus 4x. So that's 2 pi times minus 1/4 x to the 4th plus 5/3 x cubed minus, it'll be 2x squared from 1 to 4. So that's 2 pi times 1/4 times 4 to the 4th minus 5/3 times 64 minus 2 times 16. Then plug in the 1, so that'd be minus 1/4 plus 5/3 minus 2. Negative 1/4 times 4 to the 4th minus 5/3 times 64 minus 32. No, it's plus, isn't it? Plus 5/3. Sorry about that. Plus 5/3. Always make sure of my signs. So it's minus 1/4. I got the signs right here, don't I? Minus 1/4 plus 5/3, 64. Okay, yeah, that makes more sense. Minus 32, and then that would be plus 1/4, minus 5/3, plus 2. I get 11 1/4 times 2 pi, which is 23 1/2 pi, also known as, is that right, 22 1/2 pi, thank you. Yeah, something didn't look right because I knew it had to be 45 halves pi. Either one. Now, real quick, what I would say, if I rotate x equals f of y, I'm talking about the regular, got an f of y function. And I rotate that about the x-axis, I'm going to want to integrate with respect to y there, from c to d. Right? If it's an x equals f of y, and it's something like that, that's not going to be easy to change over back to y equals f of x. So that's about the x-axis. That's also shell method because I want to integrate with respect to y, and that's parallel to the x-axis. That's shell method, but it's in terms of y. And guess what it is? It's not 2 pi x f of x. It's the counterpart, 2 pi y f of y. Yeah. So anyway, just wanted to note that.